test a 4K Service GFI without pushing the test button or causing it to trip, several methods can be employed. Firstly, a megohmmeter can be used. Begin by disconnecting the GFI from the load. Then set the megohmmeter to 500 volts direct current. Measure the resistance between the line terminals and ground. The resistance should be over 1 megohm, which is 1 million ohms, to indicate there is no leakage. Secondly, a leakage current tester can be used. Connect the leakage current tester to the line terminals of the GFI. Turn on the GFI. The leakage current should be below 5 milliamps to pass the test. Regular maintenance procedures are crucial for ensuring the GFI operates correctly. A visual inspection should be performed. Inspect the GFI for any physical damage, loose wires, or corrosion. If possible, visually inspect the coil for any signs of damage or overheating. Regularly trip the GFI by pushing the test button to ensure it is functioning properly. To determine if a GFI unit is malfunctioning, a power-off test and a power-on test can be performed. For the power-off test, turn off the power to the GFI. Measure the resistance between the line terminals and ground. The resistance should be approximately 0 ohms. For the power-on test, turn on the power to the GFI. Measure the voltage between the line terminals and ground. The voltage should be approximately 120 volts alternating current. If the power-off test results in high resistance, or the power-on test results in no voltage, the GFI may be malfunctioning. It is recommended to regularly schedule a certified electrician to inspect and test GFI devices for optimal safety and reliability. Ground fault circuit interrupters, or GFCIs, are essential safety devices designed to protect individuals from electrical shock. They work by monitoring the current flowing into and out of a circuit. If there's an imbalance, indicating that current is leaking to ground, the GFCI quickly trips, interrupting the circuit and preventing a potential shock. Regular testing and maintenance are vital to ensure that GFCIs are functioning correctly. The test button on a GFCI simulates a ground fault, allowing you to verify that the device is capable of tripping. However, there are situations where you might want to test a GFCI without using the test button. This could be because the test button is inaccessible, you want to perform a more comprehensive test, or you want to avoid disrupting the circuit. Using a megohmmeter provides a way to assess the insulation resistance of the GFI. Insulation resistance is a measure of how well the insulation in an electrical system prevents current from leaking to ground. A high insulation resistance indicates that the insulation is in good condition and that there is minimal leakage current. To perform this test, the GFI must be disconnected from the load to avoid false reading. By applying a direct current voltage, typically 500 volts direct current, the megohmmeter measures the resistance between the line terminals and ground. A reading of over 1 megohm, or 1 million ohms, suggests that the insulation is intact and there is no significant leakage. If the resistance is lower, it could indicate a problem with the GFI or the wiring connected to it. A leakage current tester offers another method for testing a GFI without tripping it. This device measures the actual current that is leaking to ground. GFCIs are designed to trip when the leakage current exceeds a certain threshold, typically 5 milliamps. By connecting the leakage current tester to the line terminals of the GFI and turning on the GFI, you can measure the leakage current. If the leakage current is below 5 milliamps, the GFI is considered to be passing the test. If it is above this threshold, it could indicate a problem with the GFI or the circuit it is protecting. In addition to these testing methods, regular maintenance is essential for ensuring the long-term reliability of GFCIs. This includes visual inspections to check for any physical damage, loose wires, or corrosion. Physical damage can compromise the integrity of the GFI and prevent it from functioning properly. Loose wires can create a fire hazard and can also interfere with the GFI ability to detect ground faults. Corrosion can damage the internal components of the GFI and reduce its lifespan. If possible, visually inspect the coil for any signs of damage or overheating. The coil is a critical component of the GFI, and any damage to the coil can affect its performance. Overheating can cause the insulation on the coil to break down, leading to a short circuit or other problems. Regularly tripping the GFI by pushing the test button is also an important part of the maintenance procedure. This ensures that the GFI is capable of tripping and that the internal components are functioning correctly. If the GFI does not trip when the test button is pushed, it should be replaced immediately. In cases where you suspect that a GFI is malfunctioning, there are some additional tests you can perform. The power off test involves turning off the power to the GFI and measuring the resistance between the line terminals and ground. The resistance should be approximately 0 ohms, indicating a direct connection to ground. If the resistance is high, it could indicate a problem with the grounding system or the GFI itself. The power on test involves turning on the power to the GFI and measuring the voltage between the line terminals and ground. The voltage should be approximately 120 volts alternating current, indicating that the GFI is receiving power. If there is no voltage, it could indicate a problem with the power supply or the GFI. If the power off test results in high resistance with the power on test results in no voltage, the GFI may be malfunctioning and should be replaced. It is important to note that testing and maintaining GFCIs can be dangerous if you are not familiar with electrical work. It is always recommended to consult a certified electrician to inspect and test GFI devices for optimal safety and reliability. They have the knowledge, skills, and equipment to perform these tasks safely and effectively. An electrician can also identify any potential problems with the wiring or grounding system that could affect the performance of the GFI. Ground fault circuit interrupters play a critical role in protecting individuals from electrical shock. By understanding how to test and maintain these devices, you can help ensure that they are functioning properly and providing the protection they are designed to offer. Regular testing, visual inspections, and professional maintenance are essential for keeping GFCIs in good working condition. Furthermore, the principles behind GFI operation and testing can be extended to other types of electrical safety equipment and procedures. Understanding insulation resistance, leakage current, and grounding systems are fundamental concepts in electrical safety. These concepts are relevant to a wide range of electrical applications, from residential wiring to industrial equipment. While learning about these topics, you can improve your understanding of electrical safety and reduce the risk of electrical accidents. When performing any electrical work, it is crucial to follow all safety precautions and to wear appropriate personal protective equipment. This includes wearing insulated gloves, safety glasses, and appropriate clothing. Never work on electrical equipment while it is energized, and always verify that the power is off before beginning any work. If you are unsure about any aspect of electrical work, it is always best to consult a qualified electrician. Electrical safety is a shared responsibility, and everyone should take steps to protect themselves and others from electrical hazards. Ground fault circuit interrupters are an important part of a comprehensive electrical safety program, but they are not a substitute for safe work practices. By following these guidelines, you can help ensure a safe and reliable electrical system. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult a qualified electrician for any electrical work or safety concerns. There are several common misconceptions about GFCIs that should be addressed. One misconception is that GFCIs protect against all types of electrical shock. While GFCIs are very effective at preventing ground faults, they do not protect against shocks that occur when a person comes into contact with two energized conductors. Another misconception is that GFCIs last forever. GFCIs have a limited lifespan and should be replaced periodically, typically every 10 to 20 years. A third misconception is that GFCIs are only needed in wet locations. While GFCIs are particularly important in wet locations, such as bathrooms and kitchens, they can also provide valuable protection in other areas of the home. It is important to understand the limitations of GFCIs and to use them in conjunction with other safety measures. These safety measures can include using properly grounded outlets, avoiding the use of extension cords, and keeping electrical appliances away from water. It's also worth noting the evolution of GFCI technology. Modern GFCIs are more sensitive and reliable than older models. They are also available in a wider range of configurations, including receptacle GFCIs, circuit breaker GFCIs, and portable GFCIs. The choice of GFCI depends on the specific application and the level of protection required. Receptacle GFCIs are typically used in individual outlets, while circuit breaker GFCIs protect an entire circuit. Portable GFCIs are useful for temporary applications, such as construction sites. When selecting a GFCI, it is important to choose a model that is listed by a recognized testing laboratory, such as Underwriters Laboratories or Canadian Standards Association. These laboratories test GFCIs to ensure that they meet safety standards and perform as expected. The listing mark on the GFCI indicates that it has been tested and certified by the laboratory. Furthermore, the installation of GFCI should be performed by a qualified electrician. Improper installation can compromise the effectiveness of the GFCI and can even create a safety hazard. The electrician should follow the manufacturer's instructions and all applicable electrical codes. It is also important to educate yourself and others about the importance of GFCIs and how to use them properly. This includes explaining how GFCIs work, how to test them, and what to do if they trip. By raising awareness about GFCIs, you can help prevent electrical accidents and save lives. Consider that in commercial and industrial settings, more rigorous testing and maintenance procedures may be required. This can include more frequent inspections, specialized testing equipment, and detailed record keeping. The specific requirements will depend on the nature of the business, the type of equipment used, and the applicable regulations. It is important to consult with a qualified electrical engineer or safety professional to develop a comprehensive GFCI program for your workplace. Remember that GFCIs are just one component of a safe electrical system. A well-designed and properly maintained electrical system should also include adequate wiring, grounding, and overcurrent protection. Regular inspections and maintenance are essential for ensuring that all components of the electrical system are functioning correctly. In addition to GFCIs, there are other types of safety devices that can help protect against electrical hazards. These include arc fault circuit interrupters, or RFCIs, which protect against fires caused by arcing faults, and surge protectors, which protect against damage from voltage surges. It is important to consider all of the potential electrical hazards in your home or workplace and to choose the appropriate safety devices to mitigate those risks. The decision to install GFCIs, RFCIs, and surge protectors should be based on a comprehensive risk assessment. This assessment should consider the type of electrical equipment used, the age of the wiring, the environmental conditions, and the potential for human error. It is also important to stay up to date on the latest electrical codes and safety standards. These codes and standards are constantly evolving to reflect new technologies and improve safety practices. By following these guidelines, you can help ensure that your electrical system is safe, reliable, and compliant with all applicable regulations.